Forces are vector quantities that pull or push on objects. This video is going to take a look at Newton's 3 laws of motion. These laws, they give an outline of what forces are and what they do. Newton's first law is a law of inertia. Newton's first law states that a body at rest will remain at rest, or a body in motion will stay in motion, unless acted on by an external net force. In other words, things keep doing what they're doing unless they're forced to not. Most of the difficulty with this comes from real-world drag. If you push on a block of ice, it's going to keep sliding. Because of friction and air resistance, it's going to come to a stop, but if we could do this without friction and air resistance, that block would keep sliding forever. The easier example might be space. If you've watched shows or movies that take place in space, there's always some scene where someone is outside the spaceship, probably doing repairs or something, and there's a risk of losing contact with it. That somehow or other the person is going to get bumped away from the spaceship and they are just going to float away forever into the dark. That's inertia. There's nothing to stop them. They're moving with some velocity, even if it's slow. That's just going to keep on forever. The other major example is turning. Anytime you're turning, your velocity is changing. Even if you turn at a constant speed, the direction of your velocity is changing. When you're in a car that turns to the right, this is my top-down view of a car. That is boxy. Not any better. You're driving some kind of a cargo truck. That might be a top-down view of that. And it's moving along this way. No big deal. Then it starts to turn. Now, we run into some trouble. It feels like you're being pulled away to the left, but there's nothing that's actually doing that. Your body's trying to keep moving in a straight line, but the truck, it just isn't there anymore. Right? Maybe the truck is here now. Your body wants to keep moving in a straight line, but that's not where the car is anymore. So it feels like you're being pulled to the left. That's Newton's first law. Newton's second law, this is the math one. Second law states that the acceleration experienced by an object is directly proportional to the net force on the object. In equation form, it looks like this. The sum of forces acting on an object is equal to the mass times the acceleration of the object. This thing is an uppercase Greek sigma, and it means the sum of. So if we take all the forces acting on an object, then that's going to be equal to the mass times the acceleration. The mass kind of acts as a buffer. If we have an object with a big mass, then the same amount of force will give a smaller acceleration. So if I apply a certain set force onto an object, and I've got an object with a high mass, I'm going to get a low acceleration. If I've got an object with a low mass, I'm going to get a high acceleration. If I have a tennis racket and I take a swing and I happen to hit a housefly, that housefly has a very small mass. It's going to feel that. It's going to go flying away like it's going to be launched. If I take that same tennis racket, same amount of strength of swing, and I swing at a bowling ball, that bowling ball weighs a whole lot more than a housefly. With the bigger mass, it's going to feel a much smaller acceleration. It's not going to be affected nearly as much. Force and acceleration are both vector quantities. Mass is a scalar quantity. If force and acceleration are both vectors, that means that they will need to point in the same direction as each other. If the mass could be a negative number, then force and acceleration could point in opposite directions, maybe, but even then you couldn't have force pointing to the left and acceleration going up or something. They have to be parallel. Because mass is always going to be a positive number, or zero, we're never going to have force and acceleration point in opposite directions from each other even. Newton's second law we'll end up spending a whole lot of time with. Newton's third law, this is the last one. This is the action-reaction pair. So this says that for every force, there's an equal and opposite counterforce, or for every action, there's an equal and opposite reaction. What that means is that the force that object A exerts on object B is equal to in magnitude and opposite to in direction from the force that object B exerts on object A. Or if you like, if I push on a big crate with a certain force, the crate pushes back against me with the same force. These force-counterforce combinations make what we call a third law pair. The force that A exerts on B and the force that B exerts on A are a third law pair. While Newton's first law seems like the longest one to explain, it's the second law that's going to end up getting the most attention. We'll dig into it more soon.